Good morning. I wanted to address some questions that were commonly asked yesterday. Yesterday we worked on section 3.3, the assignment problems 1 through 24, and I got an awful lot of people, either in class or through email, asking me about questions 23 and questions 24. And I think what threw people off is that they threw a curveball at you. This section was about the addition rule. Addition rule, we have one probability experiment with multiple acceptable outcomes, some of which are counted twice, and we have to subtract that out. When we get to number 23 and we read this question. In a sample of 1,000 people, 120 are left-handed. 2 unrelated people are selected at random from the sample. There's 2 events occurring here, and we're asking for them to occur in a row. This is not an addition rule question. This is a multiplication rule question. So they threw a curveball at you, addition rule chapter, they put a question in from the previous section. It's okay. We know how to do the multiplication rule. We know when we have multiple events occurring in a row, we want to multiply the probability of each individual event occurring, keeping in mind sometimes there's a conditional probability that affects the second or third or fourth event. But we can answer this. So I've gone ahead and copied this over here into a Google Sheet. I will share this Google Sheet with you when I share the video with you. In a sample of 1,000 people, 120 are left-handed. 2 unrelated people are selected at random. Find the following probabilities. First is that both people are left-handed. Again, you've got 2 events occurring here. You're going to have the first event, event 1, and event 2. The first event is a left-handed person. Well, we've got 120 divided by the 1,000 people we're choosing from. This is 0.12 as a probability. The second event, okay, we've selected one person out, so we don't have 120 left-handed people any longer. We only have 119 of them. Put an equal sign in, equals 119 divided by no longer 1,000 people, 999 people. There's a slight difference. It's not a very big difference in the 2 probabilities, but it is a difference. Okay, so our total probability of left and left, 2 left-handed people, is going to be to multiply those 2 probabilities together. So equals this number times this number. We get 0.01429. If we go back and double check our answer here, always double check, 0.014. We are correct on that question. Our second one says neither is left-handed. So if they're not left-handed, then they're obviously right-handed. Well, we can really quick equals 1,000 minus 120, and that'll tell us how many right-handed people there are. Well, there's 880 right-handed people. So, again, event 1 is going to be a right-handed person. If they're not left-handed, they're right-handed. So we have 880 divided by 1,000. And that's our probability that the first person is right-handed. And now that we've selected someone out, we now have 879 people left out of 999 people left. And we get this decimal. And again, we're going to multiply those 2 numbers. 0.774. Double check our answer. 0.774. We are correct. Lastly, it says at least one person is left-handed. This is the other curveball that they always like to throw at the end. Keep in mind, at least one person. We only have 2 outcomes here, or 4 outcomes here. We can have 2 right-handed people. We can have a right-handed person and a left-handed person. We can have a left-handed person chosen and a right-handed person chosen, or we can have 2 left-handed people chosen. Those are the only 4 possible outcomes in our sample space. They say at least one person is left-handed. That means out of those 4 possibilities, 3 of these possibilities are acceptable for what we're looking for, and 1 of these possibilities is not acceptable. And conveniently for us, when we found that letter B, neither is left-handed, That's the probability of two right-handed people. That's what doesn't work. Keep in mind, the sum of these four outcomes, the sum of all the possible outcomes, has to be 1 or 100%. So our answer here is just going to be to take 1 or 100% minus the number we found for two right-handed people in part B, 0.225226 if we round that to 3 decimal places, which we go back and double check is our correct answer. So the reason this threw everyone off was because it was an addition rule question. Don't forget, at any point in time, you can be asked about any previous topic you've been learning about in this course. Also, people also were asking me about question number 24, and I'm having trouble finding it down here. There we go. Because that's what we need to do. Question number 24. We'll read through it really quick here. Sample of 1,000 people, 525 men, 475 women, 113 are left-handed, 63 men and 50 women. The results of the sample are shown in the table. 2 unrelated people are selected at random from the sample. Again, 2 people are being selected, not a single event. 2 events have to occur. They have to occur in a row. This is, again, a multiplication rule question where we're going to have to pick our probabilities out of a two-way table. So I've gone ahead and copied these questions over here to another Google Sheet, and we'll go ahead and answer these questions. Got our table here, 63 left-handed men, 50 left-handed women, 1,000 people total. Find the probability that both are left-handed men. There's no conditional statement. It doesn't say given that they're men. It just says both are left-handed men. So, again, 2 events. Event 1 and event 2. They ask us, left-handed men, how many left-handed men are? 63 out of how many people total? 1,000 equals 63 divided by 1,000. Event 2, our second left-handed men. There's no longer 63 of them there. There's now only 62 left-handed men out of 999 people remaining. Our probability of selecting 2 left-handed men is going to be the multiplication of those 2 probabilities. 0.0039, double check our answer always, 0.004. So they've rounded to 3 decimal places. Second question. Both people are left-handed women. Almost the identical question. We're just picking the 50 women equals 50 divided by 1,000. And now we don't have 50 anymore. We have 49 out of 999. And again, we're going to equals the multiplication of those 2 numbers, 0.00245, and the book says 0.0003. So I'm going to guess that our numbers are actually a little better than their numbers because our number wouldn't actually round up. I'm going to say that they rounded it. They probably rounded this number off and then multiplied them and rounded again. So far, so good. The next question says, at least one person is left-handed. And again, keep in mind, the only thing that eliminates is the possibility of 2 right-handed people. So we're going to find the probability of 2 right-handed people. So that's what we'll do first here. We'll find the probability. I'm going to give myself a little more room here. Insert some rows here. Insert row above. So we have some more room. So first we're going to do, our goal here is going to be to do a right-handed person and a right-handed person and get that probability of 2 right-handed people. It doesn't say men or women in this question. And once we get that answer, we're going to subtract that from 1. Okay, if it says at least one person is right-handed, that means a right and the only thing that we're not allowed to have is 2 right-handed people. So, probability of a right-handed person. How many total right-handed people are there? 887 right-handed people out of 1,000. Second right-handed person is going to be 886 remaining out of 999. And we're going to multiply those two probabilities together. Okay, that's not our final answer. Our final answer is going to be to do 1 minus 0.787. We'll round it to 3 decimal places. So to do that, we'll just equals 1 minus that number. We get 0.213 is the probability of at least one left-handed person. 0.213, again, we're correct. Part D, the first person is a left-handed man. Okay, again, left-handed man equals 63 out of 1,000 people total. The second person is a left-handed woman. Okay, we selected a left-handed man. That means there's still 50 left-handed women in the sample. So equals 50 divided by 999. While we haven't pulled a woman out of the sample yet, we have pulled one person out. And our probability here is going to equal those two numbers multiplied. And we get 0.003. I know that's the correct answer. 0.003. And the last question. The last question gets a little bit trickier. One of the people is a left-handed man and the other is a left-handed woman. Part D specified an order. They said a left-handed man first, second, a left-handed woman. So that's why we did the points, or the 63 over 1,000 times the 50 over 999. This question does not specify an order. Doesn't matter. So we can do, we can have a left-handed man followed by a left-handed woman, or we can have a left-handed woman followed by a left-handed man. And either of those outcomes would satisfy this situation of one of them being a left-handed man and one being a left-handed woman. So this is where a little bit of addition rule comes in. We're going to find both of these probabilities independently, and then we're going to add their answers up because this is a possible outcome or this is a possible outcome. Keyword there being one or the other, or is the keyword. Either of these would work. Find the probability of each one, add them together. So that shouldn't be too difficult. We actually already found the left-handed man and left-handed woman answer right here. We'll go ahead and type it in again anyway. Equals 63 divided by 1,000 equals 50 divided by 999 equals that cell times that one. Okay. Now, left-handed woman, that's going to be 50 divided by 1,000. Left-handed man, that's going to equal 63 men still remaining in the study out of 999 people remaining total. Just that decimal, and we are going to multiply those two numbers. You'll notice we got the same answer. And when you think about it, that's because of the commutative property of multiplication. In this case, we had our numerators were 63 times 50, and our denominators were 1,000 times 999. Down here, our numerator of our fraction was 50 times 63. Same two numbers, just in reverse order. Denominator was still 1,000 times 999. So these two numbers should come out to be exactly the same, and we're going to find the sum of those. And we get 0.006. And that is the correct answer from the textbook, 0.006. If you had recognized that rules and properties of multiplication and knowing that these two answers were going to be the same, you could have just doubled this and got the correct result as well. So there is number 23 and number 24 worked out for you. I hope this was helpful. I will share these documents with them. You'll be able to view them. You won't be able to change them, but you can certainly make your own copy and try it yourself. So thanks for listening. I hope this was helpful.